Welcome, Padawans, to Jedi Combat 3, Serial Interfaces and Basic Setup. Whoosh! Pshush! So, it's been a while since I have uploaded some videos. I've been really busy at work, and also I finally got my rack in the mail. Thank you, UPS, for delivering it to me with a 10% bend. So necessarily shoving those guys in there isn't much fun. Once we get all of this set up, we'll have more labs hopefully soon, and more complex labs. I have a good amount of equipment here. I have several routers, layer 2 switches, layer 3 switches, so we can get more interesting topologies going. However, for now, I'd like to focus on one of the fundamentals, which would be setting up serial interfaces. I know there's a lot of CCNA students out there who don't get much exposure to serial, or even exposure to any of the hardware at work. We have lots of experience with Ethernet interfaces. We've been working on them with home routers or with our desktops, plugging it in, but not necessarily serial. It's something that's specifically associated with wide area networks, not local area networks. So let's focus on that. So kind of going forward, the router that I'm using to demonstrate this, I have a pair of Cisco 2520s. These are older routers. They came out in the 90s. They end-of-lifed, I think, sometime in the mid-2000s. They are great for studying your CCNA because of the variety of interfaces. And these guys go on eBay for under $100 easily. I think you can find them for $50 to $80. So let's look at the interfaces that are included. You have a total of 4 serial interfaces on the back here. 2 of them are high-speed synchronous. 2 of them are low-speed asynchronous, and we'll go over differentiating those in a second. We also have a 10 meg Ethernet. Now you're looking at this going, that does not look like an Ethernet port, and you're right. It is an AUI port that is used to plug into an external module that then gives the RJ45 connector. For those who have exposure to this is kind of similar to the SFPs that you might plug into a switch or router, and that is actually what your cable plugs into. Same deal, same principle. I actually didn't label here, but immediately adjacent to it, you'll see BRI0 if you really zoom in. That is an ISDN interface as well. Typical 2-channel, 128K, 2 bearer B channels at 64K each, and 1 D channel. So definitely something that you won't see now. You know, ISDN, favorite acronym, it still does nothing. Maybe you'll see it as backup, but with 4G or 3G becoming so widely available, most people aren't even considering dial backup anymore. And personally, I wouldn't recommend it either, since typically problems are with the LEC or the local service provider. So your phones will probably be affected at the same time as your data circuits. Anyway, so this is the router here we're using. Now let's kind of look at the serial interface here. What we're using is called a DCE DTE V.35 crossover cable to connect them. So first, V.35 is the physical connector used. There's a couple serial connectors. You're probably familiar with the 9-pin DBU connectors. If you look at your Cisco console cable, not the RJ45 side, but the other side, the 9 pins in 2 rows, 4 on top, 5 on the bottom, that is a DB9. There's also RS232. There's a couple different ones out there. However, the flavor that we're dealing with for this router is V.35. And to kind of give you a little bit of a closer look here, that's what this guy looks like. It's got 4 rows of several pins. Again, bit of an antiquated connector. These cables actually used to be quite expensive, but given the depreciation of serial, it's not something that you're going to be paying a bunch of money for. Lots of equipment is used online, eBay, or other specific Cisco kit resellers. So now kind of looking at this DCE DTE, reminder from your CCNA studies, that stands for data terminal equipment or data communications equipment. And this refers to specifically synchronizing. The DCE DTE specifically refers to the master-slave relationship. So when you're talking about synchronous serial, one of the interfaces is going to generate the clock. The other one is going to synchronize or slave to it. With asynchronous, what you're dealing with is interjecting start and stop bits into the data flow. So because of that, synchronous serial is going to be a little bit faster. So again, synchronous serial, you're going to have one master, one slave. You're not thinking DSM, no, children, get your mind out of the garbage. So the DCE is going to be the one that generates clock. The DTE is going to be one that synchronizes to clock. So without further ado, let's get started here on our lovely configuration. So we're in one of the routers. This is pretty much a basic startup configuration. I always like to do a show version to start these guys off so we know what are we dealing with. So as you can see, this is a 2500 series. It is running 12.3.19, a little bit older software. Kind of going down the list. Let's actually do this. You can see how old. This is a 2006 release. That's how old this guy is. And if you do not know, Cisco is actually on 15. After 12.2 came 12.4, the whole release is there, and then they skipped 13 and 14 and went straight to 15. So this gives you an idea of how old this is. Don't be confused by this 11.0. This is the bootstrap, or the think of it kind of as similar respect as the BIOS for a computer. This will, in some ways, set limitations on what iOS software that you can use, because this has to interpret it at load up. So as it's booting up, even if you have the whatever unlimited memory, unlimited flash, this right here is going to kind of be a deciding factor into what iOS you can upgrade. And in some cases you can upgrade and need to upgrade your bootstrap firmware. So kind of going down here, this is the specific file that's here. This again tells me 12.3. This right here, these letter denominations tell me that, that it is the IP plus feature set. One of the things that it supports is BGP. Going down here, you can maybe go down a little bit more. The memory. This guy is so old that what it came with is 16 megs of RAM. So as you can kind of see there, this is what we're looking at in terms of RAM. And then the flash is 32K. 32K of flash there for supporting our firmware or our startup configs and whatnot. So it also lists the interface. We have one Ethernet, one two serial, two low-speed asynchronous serial, and then one ISDN. So now let's take a look at our running config, show run. And by the way, you can tell how old these guys are just by how long it takes for the run. And actually, let me scroll up real quick. From our previous lab, notice the configuration register is set for 2102. That is normal boot. If we were doing a password recovery, it would be 2142. So here we go here. This is part of the default config service timestamps. That's just so if you're doing logging or whatnot, there will be a timestamp associated with it. About the only thing I added was this username and password. That's about it. So as we can see, we go through, there's no IP addresses. All of the interfaces are in a shutdown state. All right? And nothing's configured on Telnet. So let's kind of go through and start doing some basic config. One of the things I love to do to begin with, especially in labs, is no IP domain lookup. There we go. What does that do? Well, it prevents it from doing a DNS query. Why is that important? Well, if you enter a command that is not in the syntax, it is going to assume you're doing a DNS query, and it's going to try to ping your DNS server. And since this is a lab environment, I'm not connected to the internet, so it's going to take the full timeout period of something like 10 to 20 seconds before it finally returns, oh, I couldn't find this domain name. So I like to just disable DNS lookups altogether, certainly in a lab environment. If in a live environment, you could probably point to a public DNS server if you need to ping, say, by hostname or resolve hostnames, especially for something like NTP. Okay, so no IP domain lookup. Another little quick tip here. Lots of times we're in config and we want to look at the running config. What do we have? But no, we can't do that. If you preface your show commands with do, this can actually let you execute exec mode commands such as showing or viewing your config or interface status or any of that. So now remember how I said you have two serial interfaces, right? Two of them are going to be high-speed synchronous, two of them are going to be low-speed asynchronous. Well, how do you know? It's not like they're labeled on the back of the box. It's not like we can, for instance, look here. Which one is which? Well, you know because I labeled them for you, but I can guarantee you if you pull a box fresh out, you're not going to know. So how do we determine that? Well, let's do some show commands. First, let's start with the obvious one, show interface serial 0. Let's start with the first one on the list. And what do you see? Take a second here, pause the video, and look at this and see if you can determine for yourself. So, All right, kids, ready? So let's look and see. Let's do some output interpretation. Obviously, it's down, down. It's not turned up. It's not configured. Bandwidth 1544. Incidentally, notice what that's similar to. That is right, boys and girls. T1. So in the old days, the serial interface would go to an external box called a CSU DSU. That would then connect to the service provider, and that would give you your blazing fast 1.5 megs, which, you know, in 1995 was just super mega orgasm fast. Now, not so much. So as we're going through here, we see, notice that the speed is set here, kind of going through. Encapsulation is HDLC, that's the default. It doesn't necessarily tell you, though, if you have synchronous or asynchronous on. But what we can do, let's execute this on the last interface and get a comparison. And same deal, go ahead and pause it, take a look. Notice something? That's right, the bandwidth is 115K, about 1/10 the speed of the S0 interface. So this tells us this guy is probably the slower asynchronous low-speed interface, whereas Serial 0 was considered the high-speed. And again, you know, 1.5 was high-speed back in the day. So this right here gives us some visibility and differentiation. Let's execute a different command. I think it's show controllers. Yes, show controllers. Serial 0. Show controllers is going to be focusing on layer 1 information. All right? Go ahead and pause this and see if you find something interesting in this output. What do we have here? V.35 DCE cable. This tells us that the DCE DTE crossover cable is plugged in. And a little aside, a little note on this. This cable right here, the end that you plug in is specified on the outside. It is labeled DCE or DTE. The end of the cable that is labeled as DCE must plug into the router that's DCE. The end of the cable that is DTE must plug into the router that is DTE. It is significant. If you reverse that, you will not get transmission across that cable. I don't know if you can actually see it here. No, you actually can't. But typically on most Cisco cables, it will probably be burned into the plastic or labeled or somehow here, or possibly in the edge right here. Designate which end is DCE and which end is DTE. So this tells us that a DCE cable is plugged in. A lot of this is just kind of hexadecimal addressing you won't really get into unless you're working with TAC support. Let's issue this command for serial 3. What do we have here? No DCE cable, right? No DCE cable. Think about how this could be useful if you're troubleshooting something remotely and you don't necessarily have someone there to assist you. This is a good idea to see if the cable is plugged in and which end is plugged in. So this is kind of a nice little tip here to get some outputs on your show commands. Let's kind of start going forward now configuring this bad boy. So let's go to the configuration mode, interface serial 0. So the first thing we want to do, let's change the encapsulation from HDLC to PPP. Let's be bold and adventurous. So encapsulation PPP. Let's assign it an IP address. IP address 192.168.100.1 255.255.255.252. Let's do some subnetting here, kids. What would that do? What range would that give us? 2 usable IPs, right? This would give us a /30 mask. 0 would be the network. 3 would be the broadcast. So your only 2 usable IPs in this case, 1 and 2. Class C subnetting. Fun, fun, fun. Now the other thing we need to do, since this end is the DCE and he's generating the clock, we must specify what rate that is. So another thing you can do if you're unsure, what is my low speed interface versus my high speed? The command to set this is clock rate. So think of this as kind of in an Ethernet interface. Are you going to operate at 10? Are you going to operate 100? Are you going to hard set to a gig? Here you have a little bit more options. Oh, yes. No. No, we don't. Thank you, Bill. May I have another? So look at the options that we have here. 1200, 24, whatnot. By the way, this goes up to 4 megs, but practically speaking, 1.5 is really all you can get. And you know what? Let's quickly switch over to serial 3, do the same command, and see what our options here are. You'll notice it only goes up to 115K. So that's just another way that you can distinguish between which ones are high speed, which ones are low speed. All right, so let's go back to serial 0. Int serial 0, if my fingers cooperate with me, clock rate. Look at our options, and let's just set this for a meg. Nice round even meg. And we will no shut him. Look at that. We get a status. Link up down. Interface serial 0. Change state to down. Well, gee, we just no shut it. Shouldn't it be up? Think for a second. Why is it saying that it's down? Because the other end of the cable, the other router that's plugged in at the far end, is not configured. He's most likely down. All right, so let's exit out of here. Let's do a write mem. Tick-tock, tick-tock, tick-tock. Blazing fast. And let's do our show run. Look at our configs here. Perfect time to crunch up those Adderalls into a nice line, do them, get the energy you need for the projects on your plate. All right, so here we go. Serial 0, so we have our address and our mask. Encapsulation PPP, we have the clock rate, and he is not shut down. All right. Fair queuing from Jedi Combat 2, as you know, was a QoS mechanism. We won't cover that now since that's a whole lecture in and of itself. And so that's pretty much it. We're good. Now let's one other thing we want to do, part of good practice here. Let's actually create or set the host name so we don't necessarily get confused going back and forth. Which one is which? So we're going to label this 2520 DCE. Oh, look at that. We'll do write mem again. Okay, while that's running, let's switch console cables here, plugging into our DTE. And again, start off with our show version. All right, same deal, running the same version of software, 12.3. This is actually a twin of the DTE. Same hardware, same software. I specifically uploaded the most current version of the iOS that I could find for this guy, which is, I'm grateful it's in the 12s. Initially, these things shipped with version 11. So again, here's the firmware that's in here. The interfaces that we have, same deal, same amount of memory, same amount of NVRAM. Config register is in normal mode. All right, and let's do show run, see what we're at. All right. So again, same sort of deal. All I did was really configure an admin account. Which, by the way, you might be saying, why isn't it prompting me to log in? I typically only set these on Telnet or SSH, on the VTY terminal sessions. For a lab scenario on local, I leave it to be uncredentialed, unauthenticated. So if I do mess up and forget the password, I don't have to go through this excruciatingly painful password recovery. And a lot of times you don't. You have limited times between your day jobs and your families. You don't want to waste your lab time doing remedial stuff. Once you've done a password recovery 2 or 3 times, that's it. You'll for learning purposes, you don't need to do it again. All right, so again, nothing's configured here. All right, and just to be thorough, let's do show interface serial 0. Looks like it's the high speed. Show interface serial 3. He's the low speed. And just to verify the cable, we'll do show controllers serial 0. And yeah, look at that. Verifies that the DTE cable is plugged in. And again, just so you guys know, I'm not lying, we'll do show serial 0 2. Pick something else. And we'll see no DCE cable plugged in. All right. So now let's go ahead and configure this guy. So config interface serial 0. Again, we want to make sure the encapsulation is PPP. We'll assign another IP address. 192.168.100.2 255.255.255.252. All right, and let's think for a second. Do we need to do clock rate? No. we need to do nothing else but no shut this guy. He's going to be receiving clock rate from the master, synchronize up to it immediately. So all we have to do is a no shut and we're good. There we go. Link state changed to up. Let's do this now. First, let's change, you know what? God. Let's change the host name. Hostname 2520-DTE. And we'll do a quick write mem. Or a not so quick write mem. Oh yeah, blazing fast. I don't know if any of you have had experience on service provider level equipment, but sometimes restarting those, issuing a write mem can take several minutes. On a 7600 router, fully stocked, running 50 to 100, potentially 1,000 customers on it, will take quite a while to issue a run command. So first, let's look at the interface status. So if you know these commands, great. If you don't, that's fine. That's why we're here and going through this. So first, let's do show interface serial 0, the same command we issued before. Now notice, serial 0 is up, line protocol is up. For your understanding, this first one right here is typically referring to layer 1. You have physical layer 1 connectivity. Line protocol typically refers to layer 2, data link. So PPP is up. All right. Right now, it looks like we actually had some packets going back and forth. I would imagine those would be our clocking thing. So we already have some traffic generated. Let's, before we do that, let's do some other commands. Show IP int brief. This is a nice quick little command that will show you the status of all of them. Notice that everything's down except serial 0. All right. Now let's actually start pinging some addresses here. So ping 192.168.100.1. Pinging across. Great, look at that. Now, let's get a little crazy. Let's see what happens if we ping the broadcast address. Remember, in a /30, the very first IP is the network. The next two are the IPs you can use to assign, and the fourth one is the broadcast. So .3 is the broadcast for this /30. Ping that. Let's see what happens. Hey, look at that. I think we're actually getting replies. I'm not sure what the default behavior is on some of these older iOSs, if it disables broadcasts or whatnot, but it actually looks like we're getting replies from the broadcast address. Not necessarily the most expedient. Hey, look at that. And this is something that you can definitely do to experiment and see, if you set up your address incorrect, try pinging the broadcast for a subnet. And another thing you can actually do, we'll do that next, is ping the generic all hands on deck IP address, which would be 255.255.255.255. We think we can close this guy now. It's Control-Shift, Control-C, Control-Shift-6. Yes, thank you. So I think you can also instead ping 255.255.255.255. Look at that. It's an adventure, boys and girls. It's an adventure. Networking is always an adventure. All right, let's see if we can exit this. Control-Shift-6. 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 And if you don't know, by the way, if you get stuck in a long ping, Control-Shift-6 is the sequence to exit it, not Control-C. So now let's take a look at the interface again. Show interface serial 0. We're going to see now we're getting some traffic going across here. Notice 91 packets. So let's take a second here and look at what we have in terms of interpreting problems or outputs. Input errors, CRC, cyclic redundancy check, frame errors, giants, runts. Typically, if you're not getting communication, you might see some errors here if it's a layer 2 problem. Just a reminder, CRC is what's the value that is calculated at the end of the layer 2 frame. It's sent to the destination, and then the destination calculates its value and then compares it to this tailor. And if the values are different, you have a CRC error. If they're the same, great, it checks out. So these were, you'd see typical errors. You'd see collisions, output errors, some place to look. You know, if you suspect you have a layer 2 problem, but your layer 1 is looking good, like you've tested the cables and, you know, your fluke or whatever is ensuring that you don't have any cross connect or cross pins or anything like that. What else can we do? Show interface serial 0, I think stats is what we got here. So this is kind of just the same view, more summarized if you want to just look at the packets. Let's see, show interface serial 0. What other options do we have here? You know, and this is a great way for you to learn. Go exploring. Summary. What is summary going to give us? Let's see. Okay, again, kind of the same view over what's been going in and out. So now, let's go to the other. Let me jump over real quick to the other guy. To our DCE. Show IP int brief. Look at that. So we're up and up. Show interface serial 0. Again, serial 0 is up, line protocol is up. We're looking good here. All right. So that's pretty much it for this. You know, again, this is just kind of a fundamental exercise. A lot of you guys I know don't have access to serial interfaces. It's a bit of an antiquated interface, especially since you're getting Ethernet available from service providers in Metro Ethernet, and you have MPLS running over it. You're seeing serial interfaces and DS3 interfaces less and less and less, and seeing Ethernet interfaces more and more. All right, so I hope you guys got some value out of this. More will be coming, more complex will be coming. We'll have some scenarios, kind of build out maybe a small service provider environment, hopefully once I get this rack straightened out, literally. All right, so this is the Cisco Jedi signing off.